Hi class, Professor Smith here, excited to create a video on evaluating a definite integral given a graph of a piecewise linear function. In this example, the graph of the piecewise linear function g is shown below. Use the graph to evaluate the given integral. And we have the definite integral from 2 to 5 of the absolute value of g of x dx. I'll start off by capturing the interval on the x-axis from 2 to 5. Next, I'll capture the region of g along that interval, and I'll notice that I can break it up into 3 different regions, or actually 2 if you use a trapezoid rather than a triangle and a rectangle. Since our interval starts at 2, I'll drop a perpendicular from the graph to 2 on the x-axis. And the reason why I'm dropping is because the graph is above the x-axis. Next, I will drop another perpendicular, but this time I'll go from the point 4, negative 2. But this time I'll go from the point 4, negative 2 up to the x-axis. And then since our interval ends at 5, I'll drop another perpendicular at x equal to 5. I'll shade in the 3 regions and then show you how you could also use the trapezoid formula and only have 2 regions. So my first region is going to be the triangle from 2 to 3, and I'll draw it in purple, and I'll call that A. My second region is going to go from 3 to 4. I'll color that one pink, and I'll call that guy B. And then my third region is going to go from 3 to 4 on the x-axis, and I'll highlight that one in yellow. And that will give us a rectangle, and I'll call it C. Now what I could do is if I combine B and C, that gives me a trapezoid. And so I'll highlight it in a teal color, and my trapezoid is going to go from 3 to 5 rather than 3 to 4, and I'll call that region D. When the region is above the x-axis, we can interpret the definite integral from 2 to 3 of the absolute value of g of x as just the area of that particular region, in this case, a triangle. When the region is below the x-axis, we can interpret the definite integral, like if we use region D, from 3 to 5 of the absolute value of g of x, as the same as the area that we did above, because absolute value only wants the positive or non-negative value. All right, so let's first do the 2 regions, and then I'll go back and do the 3, just in case you don't want to use the trapezoid formula for finding the area. So region A is a triangle, so I'll draw a little triangle subscript. And the area for a triangle is 1/2 the base times the height. And so we have 1/2. The base of our triangle is from 2 to 3, which is 1. And the height of our triangle goes from 0 up to 2. So it's 2. So the base is 1 and the height is 2. Canceling the 2's, we get the area A is 1. When we take a look at the area for region D, that's going to be a trapezoid. And a trapezoid has 2 sides that are parallel, and then the other 2 sides that are not parallel. So the area of the trapezoid is given by 1/2 little base plus the big base times the height. So in our particular case, for region D, the height is going to go from 0 to -2, which would be 2. And the little base would be from x equal to 4 to x equal to 5. So that's that part of our trapezoid. So that would be 1. And then the big base goes from 3 to 5, which is 2. So it's equal to 1/2 the little base, which is 1, plus the big base, which is 2, times the height, which is 2. So I can cancel the 2, and 1 plus 2 is 3. So the definite integral, because of those absolute value bars, is going to be equal to the sum of those 2 areas, because the areas are given by positive values. And so we have A plus D, which is equal to 1 plus 3, which is equal to 4. Now let's find the area of the 3 regions rather than 2. So the first region call was from 2 to 3, which was that triangle. So A is equal to 1/2 the base times the height. So that's the same as what we had before. We had a base of 1 as we went from 2 to 3, and a height of 2 as we went from 0 to 2. And we got 1. And then for B, we're going to have a triangle rather than a trapezoid. And that's going to go from 3 to 4. And then I'll drop that perpendicular to the graph of G that's below the x-axis going to the point 4, -2. Again, it has a base of 1 and a height of 2, so it's going to have the same area. And now let's find the region that goes from 4 to 5, and that's a rectangle. And I'll call that guy C. And the area of the rectangle is base times height, and the base is 1 and the height is 2, just as it is the height of 2 for the triangle. That's why that trapezoid formula works, because the height's the same. So a base of 1 times 2, and 1 times 2 gives us 2. And so when we add up all the areas, we get 1 plus 1 plus 2, which is equal to 4. So we get the same answer for the integral from 2 to 5 of the absolute value of g of x dx, which is equal to 4. So it's your call if you want to break it up and just really only know two formulas, the area of a triangle and the area of a rectangle. You're good to go. So remember that the area of the rectangle is equal to the base times the height, and the area of the triangle is given by 1/2 the base times the height.